I'll assume the stream has started, and I don't know. Well, exactly, I know what I'm trying to do here, but I don't know if the stream has started or not. So I'm pausing for a bit. But the goal of this stream is to basically document as I go through a lot of materials, and I've been like trying to build a base around this text to speech models and how things are working. And when you talk with these new models or TTS models that we have right now, um, these are like quite good. They have this naturalness, right? And they give the vibe that a real person is talking behind. And this is something that I want to attempt, but not only limited to English language or Chinese language, which for lots and lots of like models that is present in the system or present in the market right now have. What we're trying to do is we want something for Nepali language too, or let's say any language or n languages, and we have this like specialty market like Elvin Labs and all other companies, which their main goal is to sell you as an API, right? And this is not what I want. I want something like Whisper. Like Whisper is a very good ASR, right? This is automatic speech recognizer, or and like it comes from OpenAI, which is like surprising in itself, right? OpenAI did open thing, but what can you say? I want something like that, but on a big domain, and I'm trying to create a competitor for something else on our Nepali market right now. We have something called Ting Ting, and I want to like beat it. So, without further ado, let's get started. And this is very open-ended, and I might not even look at chat or things like that. My main goal is to document. So I'm really sorry. I'm really sorry if I missed your comment, or if you had something very like meaningful or something to say. Maybe later I would try to like conversion or barge into the conversation that you're trying to like create on the chat. But right now I don't have any like particular goal of talking with chat members or things like that, and I don't even like expect anyone to watch this. Maybe 10 days, 20 days, 30 days. Okay, what is this? I hate this kind of notifications. So let's get started. So as of right now, I've been like trying to go through new models like this, more like Bark, RBC, Tortoise, Magnet, Demox, Maha TTS, and a lot of things. There are a lot of things here, right? And one thing that's clear is I don't have this base, like proper ML base to like cover what is happening. Even if you have like basics of, you cover basics of machine learning, and like how things work, right? You know what let's say RL is, or you know what to say, our neural network itself is. These things, these are very superficial things, I would say. You have to gain an in-depth understanding of what's happening behind, and there is no one pipeline that you can look at it. For example, let's say random forest model, right? You can't just expect something like that, which is one pass and completes the pipeline within a single algorithm. There are a bunch of algorithms involved and a bunch of things involved in itself, and the process itself is like very big and a culmination of a lot of years of effort. So what's the goal for today? I was looking at VITs, right? VITs, variational inference with adversarial learning for end-to-end text to speech. And I'll be using ChatGPT a lot. Along with it, I have also have like set up Zotero. This is like very completely new way of learning for me. And before I even start, I think I should set up Zotero, right? So Zotero better Zotero. What is it? The plugin, something like that. Paper text. Yeah, this is the one I was looking for. And what is it? I need to go to the GitHub repo. Once I get here, where is it? Where is it? Releases. Okay, there is it. So I have releases here, right? And I just need to download this. Head to, where is it? This is a 1. No, this is a 0 1. So I need to head to, where was the plugins? Here is it. And I just need to drag, place it here. And now I have better BibTeX. Let me just see. Okay, this is fine. And next thing that I wanted to do was heading to Obsidian. There is this community plugin, which is, what was it called? I forgot, but you just type Zotero and it should, okay. This is what I was talking about, Zotero integration, and let me install that. Now that is done. You know, the only reason that I'm using Zotero is not for resource purpose, but it's a better pipeline or better workflow in general. You read PDF because Obsidian doesn't have a good PDF reader. For example, let me show you what I was talking about. I tried reading Dipt first 5,000 years from here, and well, the embedding is good. And if I just go here, like the included PDF reader with PDF plus plus, it's quite good, I would say, not that bad. You have like complete color combinations, like you can use red for something that you don't agree with an author, yellow with comments you want to leave behind and things like that. The color coding is all good, right? But this doesn't seem like a good solution, right? And like Zotero has been doing this for a lot of time, and like I can have Zotero plugin, not plugin, but what was it called? Chrome extension. Zotero connector. Yeah, this is what I was talking about. When you have Zotero connector, what you can do is you can just use Zotero connector as extension and add in PDFs to Zotero, which the workflow with Obsidian is not that like that good. You know, for creating notes, for creating links, right? Links among like a lot of ideas, Obsidian is quite good, but for reading structured text like Zotero, sorry, PDFs, I think Zotero has the edge. So I've been trying to like incorporate this to my workflow too. Okay, so I think Zotero connector is installed, and I have better big text too. What about this Zotero integration? Let me just enable it. Let's go to the settings, PDF utility. Extracting data from PDF requires an external tool. Okay, this plugin will still work without it, but annotations will not be included in exports. Okay, so PDF utility, I think I need to download, and I'm not sure if I'm gonna keep PDF plus plus in this my vault, in my Obsidian vault. And PDF utility path override database is Zotero, it's good, right? Which node first imported? Okay, citation format was saying, and you know, talking about citation format, I'm completely oblivious to this. So you know, I'm gonna ask whom. Tell me more about citation formats, and let me just get a good Google search to citation format. There must be something, right? Citation styles AE. What is it saying? So citation is, yeah, I know that. and citing resources from your research. Depends on the academic discipline involved, for example APA, okay, MLA. And I don't even know if like these things are important. Let's say if I were to publish a paper, right, what format would be like relevant to me? I'll just ask this. While working on Zotero integration, it asks for citation format and I don't know which one should I use. This is for TTS specific. Let me just say ML. I later might want a ML paper out of this. So which format should I target? Before that, let me just see what it's saying. Conventions, yes, yes, yes. How can someone else find it fast? Things like that. Two big pieces every style has in text citations, yes. The measures EPA, MLA. Chicago. I think this one is like has a very cool name. Just out of vibes I'm getting, right? Chicago might be a good choice. And look at this, the footnotes. Okay, ordering. Why isn't it thinking model? I should have like instant model. So I'm getting like, just answer me now. I don't even need a thinking model right now. While it goes on there, let me see if there are any other things that I need to look into. There are import formats. Okay. Side key. So image output maybe it should be on Zotero, something like this. And import one, I don't know what to keep here. Image output path, again Zotero, side key, image base name. Okay, there is a template file, so it uses something called nonjox templating documentation. Let me look at the templating documentation. And the first thing that I need to ask is, will I be able to change, let's say I change the template, then would my node also be updated? Otherwise I need to like put some significant effort front hand, right? Otherwise I won't have a proper, or if I want like, what do I want? If I want to change while working in between, then there won't be any leeway to change templates, right? And I would have like some I would have some extra work to do, like basically conversion, and conversion is not what I want right now. So what should I do? Should I read all this? Header content, annotation content, footer content, and I think for this kind of things, ChatGPT is like completely good at. So I'll just paste these things and give me a good template based on this. My goal. What is my goal? So let me just figure out what my goal is. ML papers, books. Maybe I'm gonna read some books too, right? So that is good for reading books too. ML papers, books, and want maybe annotations, comments, right? There are things like comments and other notes. I don't want to like make this complex. Let me just add it like this. The style in philosophical sense, it wants structured metadata and American text compatible form. So Chicago. Okay, I'm gonna choose Chicago. Let me just change that. Format 1, LaTeX and citation. Okay, output format. Okay, so this is the thing. There's a template, there is LaTeX. So how do I give LaTeX? Why is there a pandoc? Okay, it is pandoc format. Let me just say Chicago. And what did it say? It said Chicago author date. Let me just use the latest one. Who cares? Okay, so formatting is done. So there is something for Tesseract too. Okay. Let me just see where Tesseract is. Which Tesseract? Okay, there is Tesseract. So just PB copy it then. And yeah. So plan absolute. This is an option, so I'm gonna let it happen. Bibliography, template file, type to search. Let me just save this. I think it's saved by default. So new template. What template? Create. I don't know which one was it. Create new canvas. This is graph view base daily note. So insert template. No, this is not what I was wanting. PDF plus plus. So I think this is a lot of clutter and I need to change a lot of things, but this should be right. Templates, insert coordinate. Maybe let me just create. Let me just ask Google first. How to create template Obsidian. Okay. Title of the active node. What is this? Settings, templates. Okay, so let's go to settings. Then there is core plugins, and then there is templates. Where is templates? Templates. There it is, and then there is setting folder. Just delete that. New what? I'm gonna do another way then. Let me just head to documents and what's it? My vault and grep templates. Okay, dirp templates, and let me head there. What was I doing? I was trying to do something, right? I was trying to create Zotero.md, and let me just head to ChatGPT, our fairy, and it might have given me fancy but users now. Okay, some comments, separation of concerns. Any idempotent imports. What is idempotent? I think it's like switching something that's already switched on. So idempotent Okay. Mm-hmm. Annotation. Now it goes to understanding. Okay, not insights. Okay, here is what I want to do. So based on what ChatGPT said, what I want to do something like this. Um, just like Git has in staging area, right? Um, I want my imported Zotero annotations and stuff to be a staging area for like good thought and then for staging area for what for a clean I will be working my thought process. So persist annotations. Mm-hmm. Mm-hmm. Let me just look at it. There was nothing here. It says persist annotations and let me just look at docs and what do you, is there something on chat? Who is Zephyrus? Yeah, it's been a long time. I've been dormant for a long time and now there's a little bit of what do you say a confidence that I'll have a breakthrough, all this dormant kind of I've been keeping myself dormant for a good reason, mm, so that I'm able to explode when it's required. So I think this is the time. And what is it saying? My understanding, synthesis, persist synthesis, abstract. Yeah. After I go to that. Oh, that means I just can create a new file, right? So this is zotero.md. I didn't even require md. Why I'm doing this. There's something called Zotero now. Citations, bibliography. Yeah, for now this works. I'll change when it's required. I don't want to spend this much time. A single thing. So Zotero MD. Okay, I found it. Bibliography style Chicago 7th edition. Yeah, who cares? I think I care. That's why I put that much thought into that. So we have a good citation format, Zotero integration maybe. And how would I want to start looking at stuff? So one uncomfortable truth that I have to face is I didn't have exact resources that I can provide to ChatGPT or Notebook LM or any other kind of LM tools to converge and actually help the model itself to give me a high signal information. So I'm relying on what to say, information, like the model that has lack of information. What do you say that? I forgot the word, but this is not like properly optimized way. And since I plan to reiterate and keep on iterating, and when I find some kind of like, if the AI had fucked up, or if it has given me a wrong information, I'll eventually know. So this is what I'm trying to work on. Basically, I'm trying to BFS out all information here. So if I'm trying to BFS, then how should I start then? Like, I already have started and I have some thing to work on instead of TTS. And I was looking like these are all the models, and like they all have like accompanying papers. A lot of them have accompanying papers, so they would also be a good way to go through. But let me just create this base, right? Statistical base, linear algebra base, and the ML base that I require, so that when I get the hiccups around there, um, those hiccups would be, or will be, like smaller one, something that doesn't push me into a like a big rabbit hole. I want to like look into what are the aspects of it, or what are the domains that I need to know for like beforehand, before I jump into these papers. So that's what I'm trying to do, Abba. So I was looking at bits, and these are all like what I have understood. Look like text duration, mel spectrogram, vocoder and waveform, and each area was a failure mode or mel's spectrogram. Or maybe I should just convert this to something like this, right? Because I already have vocoder. I don't have something. I have something vocoder, right? So it's taking some time to load. Is there a paper? It's paper. There you go. And did I activate the pseudo connector? My library. Yes. Look at this. Like, how good is this? I just added it, and I'm sure the PDF is right into my uh, library. And why is this so dark? I hate dark. Not actually, but I hate dark on PDFs. Or maybe I should make myself accustomed to dark things, right? Because everything looks good, like it's an acquired taste, and maybe I will acquire something out of this. So what it's saying is conditional, variational, and autoencoder. Learning for end-to-end text-to-speech, and several recent TTS models enabling single-stage training and parallel sampling have been proposed, but the sample quality does not match that of a two-stage TTS systems. So what it's trying to do is something like this, and in this work we present parallel end-to-end TTS method. Like, wasn't Tacotron also end-to-end TTS method? Tacotron, here it goes, Tacotron paper, this, right? And I'm just gonna save it in, how do you save it? Something like this, and I'm sure it's already available in my library. And yeah, yeah, an end-to-end generative So, two-stage TTS systems present end-to-end TTS that generates more natural sounding audio than two-stage models. Our method adopts variational inference, augmented variational inference, normalizing flows and an adversarial training process, which means you have GAN set up, right? Generative adversarial networks, and what was it? There was something called VAE also. What was VAE? I forgot. Yeah, this is a special type of autoencoder, variational autoencoder. Yeah, autoencoders. Autoencode. What was autoencoders? Autoencoders basically allow you to condense something to a latent space. Uh, you encode information, right? You are basically, think of it like compression and information, but it's not exactly compression in like algorithmic sense or in traditional sense. It's more of a compression, like acquired compression. um, you look at the data and you understand how to compress that specific kind of data or something similar to it, and later you are able to like compress similar kind of data into what would they say, a latent vector space. And I think that was what autoencoder did, right? Yeah, compress that into compact form and reconstruct it to closely match the original input. Okay. I don't think it's like particularly like TORs, but it does the work for me right now. And then where was I? I was in bits. And why is this Zotero still opened? So it says something like this. What's purpose? Stochastic duration predictor. Okay. To synthesize speech with diverse rhythms from input text. Let me just quickly, and I don't know like how I can pass this to. Let me just create a new. How do you create a new one? So add files, add photos and files. Maybe I just can drag and drop. Yes. Let's get started. I wish there was something like an init, right, which will go through this, create something similar to what Claude does, create a file or create an internal mapping, and I think ChatGPT does that. If you're fundamentally unsatisfactory, it looks like a bag of tricks instead of. Or just scheme is a two-stage lie. Text mail spectrogram, and which you required sig-to-sig plus attention. And mail is waveform, right? Griffin limb. Yeah, Griffin limb was like, it was a mindfuck for me. And do I have something for Griffin limb? Because the first time I don't have for Griffin limb. Maybe I should create one. One of a node for Griffin limb. And displayed creates 3D problems. Alignment is learned implicitly and often unstable. The model predicts an intermediate representation. And I don't even know if this is true or not. Training is not end-to-end in information theoretic sense. Bolting on post-processing and Griffin to fix errors. Okay. Griffin limb was basically for reconstruction, right? And the spectrogram that you get, in order to convert into waveform, you use Griffin limb. So why is it saying that admits the board and Griffin limb to fix errors? Okay, let me just ask then. Griffin limb is to convert the spectrogram spectrogram output to waveform, right? What does it have to do with smell? I understand that it's a deterministic process. The algorithm itself for I don't even know if it's deterministic, but I'm just hinting because that's what I understood, right? You have a spectrogram and you basically try a bunch of things. What was it? I need to revise on what Griffin Lim actually. Maybe I have something on spectrogram on Griffin Lim. Okay, male spectrogram. Yeah, this is time male band, and it's log scaled. And spectrogram is basically a lot of FFTs in sequence, right? This is a single line is representing Fourier transform, right? And the colors itself, these are present because we want some kind of third dimensionality in this 2D kind of image. So we know that what Fourier transform does, right? You basically taking a signal and its amplitude and its all these things and like letting it pass into the frequency domain, and the frequency domain what we have is you have a window length, okay, and you segment it out and you do STFT, which is basically you get FFT of this window length, right? And then you basically turn it and you convert it into the colors. That's what you are seeing right now. Yeah. And human purposes, humans can't. Yeah, like you get a spectrogram, but the mail itself is in log scale, I think. Yeah, log scale energy. I haven't written anything about Griffin Lim. Give me some primer on Griffin Lim. I forgot. And maybe it's a good time to create Griffin Lim too. Right, and I hate this kind of thing. Let me just create it, a capitalized version of it. Conversion is waveform, yeah, and this is not just a technical detail. The STFT of a signal gives you complex numbers. Yes, the magnitude theorem keeps only max omega and t. Okay, and throws away the phase. The phase is important. Two waveforms with identical magnitudes but different phase can sound. Yeah, completely different. So the inverse problem is imposed. Given only magnitude, guess the phase. That sounds reasonable. It's a projection algorithm. Let me just write it down this way. Or maybe medium theta. We find a better explanation. What is it then? Is there a doc license? There is web file, demo code and audio utilities. What is this? FFI to FFT bin, mail filter bank. Okay. Mail filter bank, STFT for reconstruction, ISTFT for reconstruction, gate signal, reconstructor signal, Griffin, save audio to file. So where is this entering point? There is arc bars, mid scale filter. Okay, this is color bar. What is this? Maximum value in magnitude spectrogram. So STFT for reconstruction. Okay, I need to go to STFT for reconstruction. First off, it gets the signal, right? It gets the signal, and then so you are converting it to mono, and then hop sampler shifted. Okay, these signals are converted into why is it taking an audio file? Okay, it's taking an audio file, then creating a spectrogram out of it, and then again converting into an audio file. That might be what it's doing. And this window, okay, the window for 40,000 hours and hop sample is 256, then yes, yeah, this is what we understood from the windowing thing, right? And STFT for all of these hop samplers. So STFT hop sample, yeah. You are getting an hop sample, yeah. STFT for reconstruction. Okay, you got STFT. Then the STFT is complex value. Therefore, to get a magnitude spectrogram, we need to take an absolute value. Okay, so you take an abs and you get the magnitude, which I think it's quite clear, right? Absolute. You create a vector and you get run an absolute through it. You get a magnitude. So magnitude, and why is it multiplying by 2? It's not multiplying, it's exponential. Okay. But I forgot this simple thing, absolute complex number. Yeah. That's what we're trying to do. Absolute value that. Yeah. So magnitude, you got a square plus b square form. No, but this itself is a magnitude, right? Why you are multiplying it? Maybe I'll look into it. The scale, okay. The scale contains the magnitude, so we have lost the phase information. Okay, this is what we wanted. So this is a very good example to actually look at, right? And complex valued to get the magnitude absolute value by value, and contains the magnitude, so we have lost the phase information, yes. And what was Amex doing? I forgot what Amex is. What the argmax? NumPy Amex maximum value. Okay. Just look at the complete. Dinnaga. Like, why should I fucking rely on this AI? And it gives me an example, yeah. So this is the new thing. This is so good, but bad at the same time, Bunny. What? I don't even have any thing to say on this. I guess this is a new way of programming. This is a new way of understanding things. I'm on all for it. So we have this Amex, which gives me the largest value among this. Sure. And figure, I'm not even concerned with this. So middle scale option is enabled. Perceptual frequency scale, yeah, you're converting into basically log decibel scale. Male, okay, you got that. And I'm not concerned with these figures. More figures, linear scale. And now what it's doing is we can do a low pass filter by simply setting all frequency bins above some threshold frequency भनेछ हैन. So before I do that, what was this? Give me the maths behind male spectrum, not male spectrum, Griffin link. Let me just look at the mathematics behind it. So if it's setting all the frequency bins of some threshold frequency, arcs cutoff frequency to 0 as follows, and it's calculating corresponding bin index, cutoff bin, STFT, okay. And I think I'm spending a little bit more time here, which I should have done, but discrete time signals in STFT is, yeah, E minus and omega n minus m for this. And this is a complex value, yes. X E phi given only, yeah, the magnitude. So among them it's figuring out what's the minimum value for which these magnitudes match. So sort time Fourier transform of the x itself, because we have it available. So consistency STFTX for some real x, again constraint, the situation monotonically decreases, descent convergence to the local stationary point, yeah. Reconstructs the waveform from spectrogram, yeah, it's like you match the target. As the boyo, and you give them basically what it's doing. ये तो देखाइरहेछ. And then minus m. Okay. Whatever this is. So a magnitude constraint set consistency constraints it, and the Griffin limb iteration. Okay, reconstructs the waveform from a drum, right? Okay, you're getting magnitude only. Now if I look at this, save audio to the file, X reconstruct. So this one is Ramayana Halka, I think. Reconstruct signal Griffin limb. So magnitude spectrogram, you get an FFT size, so it's upsampler and iterations. So what it's saying is from a paper. Signal estimation from modified short time Fourier transform and SI. Signal estimation from modified short time Fourier transform and necessary the rows. Reconstruction angle, and there is a proposal spectrogram and inverse of STFT for reconstruction. And there is this difference square root of what? Sum of okay, divide. Like this is going bouncer for me right now. First off, it is an inverse STFT for reconstruction. Okay, and there is this proposal spectrogram, and you are basically iterating until n is greater than 0. Oh, while n is greater than 0. And so how many iterations we want to go, and then you first have an STFT for reconstruction, right? You get an STFT. No, this is actually not giving you an STFT. It's getting okay. You are giving X, right, or time domain signal, yes. And if you're giving a time domain signal, of course you can create a frequency domain one, right? And size, yes. The rows are the time slices and columns are the frequency beans, and inverse of that is you get an inverse STFT, right? So reconstruct signal Griffin limb is using both that. Okay, it's doing something, yeah. It's using random. And I think I'm getting use this and explain to me. Okay, I think I get it. You are basically, what it's doing is, so how many samples you want to take, right? And we are just randomly feeding it in data, okay? And we are keeping feeding in data such that STFT, yeah, there was some error in that formula that ChatGPT provided, or it wasn't like terse enough or verbose enough. Not a black box mail stuff, yeah. So you have this hanging window, and you create an STFT for this. And it does all that magic, Gaba. This is so awesome. Real signal, yeah. And then magnitude correctness. Yeah, I was exactly looking at this random number length samples. So you initialize a normal distribution between 0 and 1. And what is it saying? Isn't that what it's saying? Normal distribution. Or equivalently, okay. Magnitude. What is this? Random phase initialization. Force consistency. Projection into that. STFT go as so you STFT into this. Then there is arc. Clamped and phase is reused. Magnitude is clamped and phase is reused. You keep on doing and eventually you get yes. You keep on doing it and you eventually converge. Yes. Magnitude is clamped and phase, but administration and again what is it, why do I need to look it up? And number of samples are inside random numbers, an array of random numbers, and then like this is not even important, iteration step by step, this is the most important part, but like what we get is not even important. So you enforce the consistency, so you reconstruct that random stuff, and you've got an angle ray, so you have this and you have a phase out of this होइन अनि त्यस पछाडि you get a like okay, now this is doors क्या, this is what I wanted, you need a hat क्या on top, so you know कि this is a random stuff भनेर, or this is an estimate भनेर, this is a projection onto x such that x is STFT yada अनि त्यस पछाडि you got a phase, and does that fucking phase match the magnitude that you have right now? If you ask that simple question, then magnitude spectrum भनेर छ, so k plus 1 को लागि fi so proposal spectrum आइहाल्यो होइन, त्यसको म्याग्निट्युड वाला पनि भइहाल्यो, अनि त्यहाँबाट रिकन्स्ट्रक्सन एङ्गल भनेको त्यही नै आइहाल्यो, फेजवाला कुराहरू पनि भइहाल्यो, अनि त्यस पछाडि म्याग्निट्युड आयो, डिरेक्सन्स आयो, डिरेक्सन निकाल्नु पऱ्यो, वेयर इज द डिरेक्सन कमिङ फ्रम भने त भने, सो दिस प्रोजेक्सन म्याथ भयो, प्रोजेक्सन इन्टु दिस yeah, you get the magnitude. Okay, we got a new phase, अनि त्यस पछाडि the magnitude that we had already from the spectrogram, we already have that नि त होइन, अनि that was generated by our tacotron भनौँ न. So tacotron already generated a magnitude for us, magnitude almost in a sense. We have spectrogram in itself, and you have a bunch of windowed STFTs, right? And for inverse you need an angle, and before you do that, what you need to do is the phase that you have right now, or the new thing, that the new angles that you've got, you use that, you keep on using that until you reach the magnitude that satisfies no, the magnitude is already present, or until you reach the phase that you want. Isn't that what I'm saying? Let me just close this out first, and it's not normal maybe, but it doesn't even matter. Like, I'm stuck on so small things. Fuck undergraduate degree, like I've been sleeping. Yeah, it's a normal distribution. And what is this variance and mean? And normal Gaussian distribution, yes, probability distribution over real numbers. Of course it is a probability distribution over real numbers, Gaussian, and all the fancy fucking math. Look at the variance, the mean is 0. Okay. So, in a plain terms, what I understood is, you get before I'm like converging into that, I need to understand the previous thing in this code, ISTFT, yeah, upsampler. The size. Another confusion when you ISTFT, already have a spectrogram for which you can I haven't even understood that core concept. I fucking forgot. I understood before, but it's been like 2-3 months, and now I am completely lost. Spectrogram. You can ISTFT and get a bunch of reconstructed time domain signals. Why just don't patch them together? Fuck you, ChatGPT. Like, why are you trying to be such a sycophant. This frame inversion, yeah, no spectrum, and yeah, this is an overlap add. Phase, yeah, a phase of a signal determines where it's available on, you know. So a phase of a signal determines where it's available. So what was I trying to do in the hey? Let me just see if there are any. Yeah, he's watching. I don't know if you're watching or not, but I'm just trying to explore things, and this might, since this is like first day, even I'll have hard time explaining what I'm doing. So that's how lost I am right now. For each time frame, I have a spectrum, and I can IS, TFTS, I can do that, and that must all be on shared samples. Let me just be clear. Yeah, phase of a signal. I understand in electronics, right? 180 like three-phase signal systems. It defines plus phi, sine theta plus phi. That's a phase, right? Phi. Like where you start. Like determines like when you start from 0 comma 0, the vertical axis, like okay, okay, I understand that you don't have a phase, and when you don't have a phase, you don't have, each frame is consistent with neighboring frames, and overlap added samples line up correctly. Did independently with an arbitrary phase, and for overlapping samples, yes please. Like there's this weird noise coming out of outside, like a child is singing. I don't know what it is. XMM fan is that becomes, since these two things overlap in time, sure, and overlap add becomes that again. M plus n, m plus 1, okay, what are you even doing at this point? Okay, x of n is this. Random cancellation, unequal clicks, metallic, ringing, tempering. Oh yes. Yeah. Destroy this thing now. is nearly equals to omega omega t sine omega t, and then we'll add with STFT, sleep magnitudes, lapse energy. Directly in time domain. Yeah, another phase. We're throwing phase. That's why you're using Griffin name. What happens when you throw a phase and then this is not what I was looking for. Okay. If I randomly permute STFT phases across frames, magnitude identical, the magnitudes are identical, okay. That wouldn't work, Ainara. Permute. Oh, this is what Griffin is. Isn't this what Griffin is doing, but in loops? Random permute STFT phases across frames would keep magnitudes identical. What happens? Oh, it doesn't. Random phase once. Yeah. So every time it uses previous iteration phase, but the starting point is random. Got it. From structure. Because the time is random, the object will not. So name is non-deterministic. Dependent on the random. If we take the initial randomness as a true randomness, I was wrong at the first time. So that's what it is doing. But I need to look at some mathematics again. These mathematics are killing me right now. Oh, come on, man. Like I understand half of the things and half of the things I just assume, and that's bad, right? Uh, what's taking sample n plus 1 m n. Okay, time goes by so slowly. Oh, I'm trying to understand this. X of m n minutes, so x m plus n 1. So like bunch of data in, and you have frequency beans. Okay, these all are frequency beans, and for each the frequency beans you have what? Mm, for each of the frequency beans you have, no, you don't have an amplitude, you have the numbers, right? You have the numbers. Oh no, it's not the numbers, it's the amplitude itself. Like this frequency stuff for this amplitude, that's what's happening, right? So you have the frequency and the amplitude, right? And is it like something like an array? It's not like something like an array, right? I need to explain this, like explain this math. Signal x of n. So the signal was that. And when you say signal x of n, is it in frequency domain? Is frequency and its corresponding amplitude. Note. Oh, fuck. And so that is what is tripping me. Yeah. is 2 pi f, right? Yeah, isn't 2 pi f. What's an angular need? I think I need a